Here's another trig modelling exam type question. This one's from a linear exam paper. I think it's from a practice paper. What's going on here is we've got a model of the flight of one of the birds in a bird colony, and it's the height of the bird above the ground with respect to time. So the bird is in its nest at the start of this model, excuse me, and then it looks like it kind of dives down near to the ground, and then it flies back up again. So what we've got to use is this formula here. Now, question 1, it says the seabird's nest is 20 meters above sea level. We've got to find a complete equation for H. Now, H is almost complete. The only thing we need to find is the value of A. So we can use the fact in part A, we know that when t equals 0, we know that the nest is 20 meters above the ground. So we know that H equals 20 when t equals 0. So if we just substitute those values in, we've got 20 equals 140 over A plus 45 sine 20 minus 28 cos of 20. Our sine of 0 is going to be 0. Cos of 0 is going to be 1. So we're going to have 20 equals 140 over A minus 28. So solving that equation is going to give us, well, A minus 28 equals 7. So A will equal 35. So we have to find a complete equation for H. So we need to write down the final answer, which is H would equal this: 35 plus 45 sine 2t minus 28 cos 2t. So the whole point of part A was to find out what A is. In part B, we have to work out what alpha is in this equation here. It's not really connected with the modelling at the moment, the model of the bird's flight at the moment. We just need to work out what alpha is, which comes back to what we've been doing in the previous videos on r sine x plus alpha. Got to be slightly careful here, but because it's 2, it's not x, it's 2t, but that doesn't really change too much. So we do what we normally do for these kind of questions. If you want to work out, well, actually r is already given in this question, so r is 53. It's just alpha we need to find, and it's not actually plus here, it's minus. But if we do our expansion like we normally do, if we do our expansion for sine x minus a minus b, so if we do the addition formula for sine, we're going to have 53. We know it's 53, and we're doing an expansion for sine 2t minus alpha. So our expansion would be sine 2t cos alpha minus cos 2t sine alpha. Remember, that's just the addition formula for this. We're doing a, it's just like a minus b, and we know that we've got 53 here and a 53 there. Just tidy that up a bit. So we've got minus 53. And in the question, we're given this information. So if we write that down underneath, we've got 45 sine 2t minus 28 cos 2t. And we've done lots of these questions before. We know that sine 2t and that sine 2t. So that means that 53 cos alpha is going to equal 45. 53 cos alpha equals 45. We also know that there's cos 2t and there's cos 2t, so 53 sine alpha will equal 28. 53 sine alpha equals 28. So if we divide these now, we'll find the 53s will cancel and we'll get tan alpha is 28 over 45. So if we do inverse tan, we're in degrees in this question. So alpha is going to equal, I got 31.9 degrees for that. So I think that's the answer to part B there. In part C, we want to find the minimum height of the seabird. So we want the minimum h can be. Don't forget, we've worked out that A is 35. We did that in part A. And we've also worked out that this value of alpha down here is 31.9. We've just done that in part B. So that will probably help us for part C, because we want to find, we know h is 140 over 35 plus, and then we can replace all of this with what we found in part B. So that will be 53 sine 2t minus 31.9. Okay, so if we want the minimum h, the minimum value of h is going to be when the whole denominator is at its maximum. So we want this to be at its maximum because we want to do 140 divided by the biggest number possible. So the maximum that denominator can be will be when sine equals plus 1. So when sine equals plus 1, which is the maximum value sine can be, we'll just be left with a 53 over here. 53 times 1 is obviously 53. So the minimum h can be is 140 over 35 plus 53. And you just type that into your calculator, you work that out to be, I got 1.59 to the nearest centimetre. You could write it as 159 centimetres, but you don't have to. You can leave it in metres, but to 2 decimal places. Now in part D, the last part of this question, we've got to find the limitation on the value of t. T is the maximum time that this model will work for. Now if we look at the graph, we go back to the graph right at the top here, back to the bird's flight, you can see that the model will work fine for the time all the way down here, but there will come a time where this graph will tend to an asymptote, because the gradient will be vertical. So we need to find, where does this give us an asymptote, this graph? That value there will be when the time is at its maximum value, which is called capital T in this question. So we've got to work out where we get an asymptote from this equation, and the asymptote will be when the denominator equals 0, because that is when the equation will be undefined for. So we need the whole denominator to equal 0. In other words, we need all of this to equal 0. We've got to find where does all that equal 0. So let's solve that then. So we want to solve 35 plus 53 sine 2t minus 31.9. We want to solve that equal to 0 because we need the denominator. We want to find where the denominator equals 0. So if we do that, you can rearrange this. So we've got sine 2t minus 31.9 equals minus 35 over 53. Do inverse sine and you'll get 2t minus 31.9 equals minus 41.9. Remember, we're in degrees, not radians. Now that isn't very good. That isn't much use, because when we add this and divide by 2, that will give us a negative value. So that will probably correspond, if we go to the graph up here, that would probably correspond with a value. If we were to go before 0, we would probably have got an asymptote over here somewhere. But so that would give us that value there, but we don't want that value. We want this value over here. So we need to find a different value for this. But as usual with these kind of questions, you can use the cast diagram, which I like to do. So where sine is negative, so it's going to be down here and down here. We've got 41.9, so we're going to have 41.9 over here. And we're looking for the first positive value. The first positive value will be that angle there, which is 180 plus 41.9. So the value we want really is, I got 221.3. That's, like I said, 180 plus this is 221.3. So that gives us 2t. So that means 2t minus 31.9 equals 221.3. So if we rearrange this to get t on its own, I got t to equal 126.6. So I think that is the maximum value. So the maximum value of time, in other words, that's capital T, would equal 126.6. So the time can be any value between 0 and you might just want to write, I think this would be fine to get the marks for this, but you might just want to finish off by saying therefore the time has to be between 0 and 126.6. I think, is this in minutes? I don't think it actually says whether this is in minutes or seconds, so I'm just going to leave it as 126.6 for your value of capital T.